So everybody should have been able to get to there based on what you already know from the first lesson. Yes? Yes, yes? He waited patiently. Yes, yes?
Yeah.
Everyone's done that, right? I will wait a moment then. I didn't think it would take that long, but obviously it will. So I'll just sit here and sip coffee. Delicious. The coffee from which I am sipping.
What's below that 5?
Huh?
What's below that 5?
A 3. Because you divided 5 by 3.
Yeah, no, I couldn't see the number.
But you don't need to see the number because you know to divide 5 by 3. What else would it be? It's Q.
Sorry.
That's not bullying you. That's exasperation with you guys asking questions that you already know the answer to. What are you confused about?
I don't know the next step.
Well, of course you don't know the next step. I haven't told you what to do, David.
Yeah, David.
Did you graph that?
Yes.
Excellent. Has everybody graphed this now?
Yeah.
All right, now, the next thing is going to be weird because you're going to have to do it by yourself. Everybody pick a number between 1 and 10. Don't say it out loud! I have to, Simran, because as soon as I say pick a number between 1 and 10, every clown in the class, 7, 3, 8, 4, and then a couple of idiots, -2, 12, because they didn't hear the between 1 and 10 part. Okay, see, here we go. Right. So, all of you will pick a number, I lie, between 2 and 10. And all of you will write that number right here. All right? Then you will take that number and multiply this whole equation by that number. Okay? Go. I'm going to use 4. Don't do what I'm doing. Do it yourself.
What's for the 27? Oh, no, man. It's different.
When you are done, you should have a new equation. Then take your new equation and isolate y. Now, what did Every single one of you notice, if you did your algebra correctly, that it doesn't matter what number you picked. When you multiplied it out and solved again, you got the exact same equation, didn't you? Right? If you did your algebra wrong, obviously you don't have the exact same equation. But if you did your algebra wrong, you should be going back and checking. Is everybody cool? No matter what number you wrote there, you got the same thing. Yes? Okay. So that tells us something. Multiplying both sides of a linear equation results in a new equation for the same line. Does everybody understand? What does that mean for us? That means we can use multiplying. And what's multiplication's ugly cousin? Division. We can use multiplication or division to change the looks of equations. Because remember, it's not changing the value, it's just changing the looks. Okay? Have we seen this in math before? Yes, we have. What's another fraction that equals 1/2? 2/4. Why? Why is 2/4 the same as 1/2? Because we multiplied both of them by 2. Multiplication doesn't change values, right? It just changes looks. Everybody cool? All right. Step 2, next thing I want you to do. Add those equations together. What? What do you mean add equations, Mr. Myers? That's crazy talk. No, it's not. You just do that. X's go with X's. 4X's plus 5X's is how many X's? 9X's. 3 plus -3 is what? No. 3 plus -3, Amrit, plus 0y equals 27. Yes?
Yes.
X equals what then? 3. Everybody cool? Go back to our previous graph right there and draw on x equals 3. Hey, wait a minute. It goes right through that solution. Right? So, what happened when I added those equations? 2 things happened. What's the first thing that happened? What happened to the y's? The y value was eliminated. And it only sounds cool if you say it like that. Eliminated. Like in Mortal Kombat when you get a fatality. I did in 1991 when it came out, and then I grew up. It's the exact same game. Nothing has changed. Still the same game. Still the same game. You still push down, diagonal, right, and middle punch to throw something. Like, nothing changes.
That's true.
I know. All right. The y value was limited. And what else happened? We got another equation through the solution, didn't we? So we got another line that went through that spot, right? Okay. Now the next one's tricky. Subtract them. What's 4 minus 5? Negative x. What's 3 minus -3?
0. -3. 6. What? Oh, it's subtraction.
6.
Negative 6.
Positive 6.
Oh my god, this is shown.
Now, I want you to graph this equation. Is that easily graphed? No. So we put it in slope-intercept form, x minus 27, y equals 1/6 x minus 27 over 6, which is the same as 1/6 x minus 3.5. Everybody cool? Okay. Take that and let's put it back on the graph. I go down to negative 3.5. 1, 2, 3.5. Correct? Right? And my slope was negative 1 over 6, yeah? So I go down to negative, go down 1, and out 1, 2, 3, 4, 5, 6. And I draw that line. What did you notice about the green line? It went right through the same solution, didn't it? So what does that tell us? Eventually, that is what it will tell us, Ekdeep, when I can slide down to right again. So, adding or subtracting two linear equations results in...
I have a question.
Can I just write this, David?
Yes.
In more equations that still share the same solution. So I can multiply them, I can divide them, I can multiply or divide each equation by all the same thing. I can add them together, I can subtract them from each other, but the solutions will all stay the same. Okay?
Okay.
David, what were you going to ask me?
It's not 3, 1. It's not 3.5.
4.5. Yes, thank you, David. Is everybody okay? And it was also a slope of positive 1/6. But no big deal. So we drop down 1 and the line goes this way. It's still going to go through. Everybody cool? Okay. So now I have a system here, yes? I would like for everybody to write one more equation that will work in this system. So what are our options? Can I multiply? Is that allowed?
Yeah.
Okay. So if I multiply what by what? No. Look at what we already did, guys. The notes are a hint to what you are learning. I could add the equations. So 4x plus y would equal 19. I could do that. What else could I do? Minus the equations. 3 minus 1 is 2x. 2 minus minus 1 is plus 3y. And 18 minus 1 is 17. I could do that. What else could I do? Multiply what? Again, it was just done 10 seconds ago in your notes. What? Yep. I added 2 plus negative 1. What do I do? What is the next thing I could do? I could multiply what? Any number through which equation? I could multiply any number, which we proved with our first exercise in these notes, through which equation? Can I do either one of them? Yes. So I could do 9x plus 6y equals 54, couldn't I? Multiplying everything by 3. Could I do 5x minus 5y equals 5? I could, couldn't I? Right? Is everybody cool? I can add equations, I can subtract equations, I can multiply equations, I can divide equations. Is everybody good? Okay. That's the basics for what we're about to do now. It shows you that you can change the original equations to something else that you want. That's the whole point of this part of the lesson. Does everybody understand it? So if the equations don't do what you want them to do, you can change them to make them do what you want them to do. Because you're in charge of math. Math is not in charge of you. Okay? David, your hand went like this, and then it went away.
When you're multiplying or dividing, do you have to times both equations with the same number?
No. All right. Turn the page over. You should be on page 238. Right above this word elimination, I want you to write the following thing. Elimination has two other names. Some people call it the addition method. And some people call it the subtraction method, which is silly because then it names it for one particular operation. And then you're like, but I didn't add them, I subtracted them. So that's why I use elimination. Okay? So, step 1, which I will do in black. Add or subtract the equation to get rid of one letter. Now guys, there's a hint here that I didn't type in. Look for opposite coefficients. Because if you add opposite coefficients, what do you get? 0. So that would eliminate, right? And then after you've eliminated, step 2, which we'll do in red, you solve for the remaining variable. And step 3, which you do in blue, you plug that back into the other one. 2 and 3 are just like substitution. All right? So let's do this thing. Let's look at this first system. Now, remember in the last one we did in substitution, we had 2 4x's, right? Here we've got something similar, but they're positive and negative, aren't they? And negative numbers mess you guys up. So even though we could use substitution, in this case, elimination is a better tool for the job. Kind of like if you have a dent in the side of your car, you can get that out using a hammer. Or you could get it out using a rubber mallet. Which is the better tool for the job? The rubber mallet, so you don't chew up the paint. Okay? They will both get the dent out, but one will do more damage. So you choose the better tool for the job, even though both tools will do the job. In this case, substitution will work this out, but it's more math. So we're going to use a better tool for the job in this case, which is elimination. Let's do so. Which variable can we eliminate? The y. Why is that, Fawaz? They have opposite coefficients. So let's eliminate it. To eliminate negative 5 and positive 5, is that addition or subtraction? It is addition. So that means I'm adding the two formulas or the two equations together, yes? What is 3 plus 4? 7x. What is negative 9 plus 23? 14. Step 1 is done. Step 2, solve for the remaining variable. What do I do there? Divide by 7. So what does x equal? 2. Now, what does this tell us in English? X equals 2. What x? Every x in that question equals what? 2. So now I just choose one of those equations and I put x equals 2 in for it. Does it matter which one I do? No. I'm going to use the first one. 3 times 2 minus 5y equals negative 9. What's 3 times 2? 6 minus 5y equals negative 9. How do I get rid of the 6? Subtract. Negative 5y equals negative 15. Y equals positive 3. Now, what is my ordered pair that should be my answer? 2, 3. What should I do as a last step? Check. Now, I already know that it works with that one, don't I? Because that's the one I did my work with. So I really only need to check which one. That one. What is 4 times 2 plus 5 times 3? 8 plus 15. Does 8 plus 15 equal 23? 23 equals 23. So did we do the math correctly? Yes. Now this is when all of you say, Mr. Myers, why didn't you teach us elimination first? It's way easier. All right. Now, stop. This was easy. What made this one easy? No, it was, David. The 5 and negative 5 made this one easy, right? Because they were the same same coefficient, but one was positive, one was negative. So it was just adding them up, yes?
I thought you meant by like this method easier.
Okay. Let's look at this one. What makes this one more difficult? I don't have the same coefficient, do I? But I look at these and I say to myself, self, I'm in charge of these equations. I can mess them up. I can mess them up and make them do what I want them to do. What is something I could do here? I could multiply. Which equation would you multiply, David? No, David, that's not what I asked you.
Oh.
I asked you which one you would multiply.
Oh, I would multiply the first one.
By what number? 3. David would like to multiply this top number by 3, which would give him what? 3x minus 6y, 21. Now, would he do addition or subtraction to eliminate that 3? Subtraction. Stop. Okay. If David were to continue on, he would continue on. Yes?
Yep.
Okay, now stop for a moment. What if I multiplied the top one by 2? What would I get? 2x minus 4y would equal 14. Now what would I do to eliminate? I would add. Are both of those methods the exact same thing?
Yes.
Is one of them right and the other one wrong? No. So would any of you ever ask, am I doing this right? If you have different numbers there than David? No. Because as you can plainly see, you can do the work with completely different numbers, can't you? So everybody, I'm going to actually do David's method because I want to do subtraction. There's a reason for using David's. So I'm going to go back here. I'm going to use David's, which was multiply the top one by 3 to get 3x minus 6y equals 21. 3 minus 3 is 0. What is 4 minus 6? Don't answer, Amrit. What is 4 minus 6? 10. Y. What is 1 minus 21? Negative 20. What does y equal? Negative 2. Is there anybody that doesn't see how we did that? Okay. Now, what does that mean for up here? Every y is negative 2. So let's choose one. Does it matter which one we work with? No. X minus 2 times minus 2 equals 7. X plus 4 equals 7. X equals 3. What then is my possible ordered pair? 3, negative 2. Then I check. Do I check the top one? I don't need to check the top one because that's the one I just worked with, right? So I need to check the bottom one. And I check the bottom one by doing 3 times 3 plus 4 times negative 2 equals 1. What is 3 times 3? 9. What is 4 times negative 2? Negative 8. Is 9 plus negative 8 1? Yes. So are we correct? Yes. Is everybody Gouda? Great. Now, let's look at the next one. Do I have anything that works? No. So I gotta change things around, yes? I got to get the same coefficient in front of either x or y, yes? What plays better together? 2 and 11 or 3 and 2? Why is 3 and 2 a good group to play together? Because they're closer together and they will both have a lowest common multiple. What? Lowest common multiple? Back from unit 3? Math from before being used now? Son of a bitch. Nobody told me we would do that. Except because all the math you needed to do this whole course you learned in grade 3. Add, subtract, multiply, and divide. So we're going to use 6. I got to get the y's to 6. What do I got to do to the first one to get a 6 there? Multiply it by 2. So I then get 4x minus 6y equals 40. What do I got to do to the second one? I'm going to multiply by 3 to get what? 33x plus 6y equals negative 3. Now, which you would think that by the 19th day of the class, that you have sat every single time you have had to say positive or negative, the real answer has been the opposite of what you have said. You would think by now you would say, self, I want to yell negative 3, but I have not been right on the last 500 times I've said anything. So I'm actually going to stop for a millisecond, and then I'm going to say the opposite thing of what I want to say, which was negative 3. I'm going to say positive 3. 3!
Wow, what if it's actually positive?
So, those 6's are the same with a different sign. So do we add them or do we subtract them? We add them. What is 4 plus 33? 37. Negative 6 plus 6 is 0. 40 plus negative 3 is 37. So what does x equal? 1. Now, where are we allowed to put that 1? Any of the 4 equations we have that has an x in it. Do all 4 of our equations have an x in them? So we can use any one we want. I'm going to do the one that nobody wants to use, which is this one with the 11, because I want to. Oh, poop. 11 times what? 1 plus 2y equals negative 1. 11 plus 2y equals negative 1. 2y equals negative 12. Y equals negative 6. Do I have a possible ordered pair? Now I check. Do I need to check this equation? No, because that's what I just worked with. So I'm going to check this equation. 2 times what? 1. Minus 3 times what? Negative 6 equals 20. What's 2 times 1? 2. What's negative 3 times negative 6? Positive 18 equals 20. Is 2 plus 18 20? Does 20 equal 20? So are we right? Yeah, sure, you betcha. Is everybody good? Once again, you may do the textbook pages, or you may do the super fun puzzle page. I know which one I would do if I was in grade 10. I would do the super fun puzzle page. Actually, as a teacher, I would have lied to you and told you that when I was in grade 10, I would have done all my practice, the textbook page and the super fun puzzle page. But of course, I wouldn't have, because I was a lazy sack of poo, like all teenagers, and I would have done the littlest amount of work possible and then blamed my teacher when I didn't get an A.
You are so smart. You're horribly working. I don't believe you.
I, of course, now, if I had to choose between the two, I would, of course, do the puzzle sheet so I would get the funny joke.